one of the questions was, oh, the graph or the?
The first, well, it was the first one on mine.
Oh, you had the.
X squared.
Yeah, the x squared plus 5. So I give you the function x squared plus 5, and then 1, and then this is not equal to 1. This was on one of the versions. You had a different function on a different version. But then I wanted to know the limit as f of x goes to 1. Yeah, so the limit of f of x as x goes to 1 is equal to 6, because this is the guy that really dictates what's going on, right? The way this function looks, it's a parabola shifted up 5 for everything except 1. Right? When x is not equal to 1, it's a parabola shifted up 5, and then when x is equal to 1, there's a hole, and it comes down to 1. So if we're talking about limits, the limit as x goes to 1 is going to be the trend. So as x goes to 1 on the x-axis, you want to know what happens on the parabola. You don't care about that hole. So you plug 1 into the parabola, and you get 6. This value comes from plugging 1 into the parabola.
It was the same thing on the other one, we could just plug it in.
Yeah, it's a similar problem. There's just a slightly different function. I think it didn't even matter because it was cubed, so you plug 1 in. Cube is 1 again. So that problem is okay, hopefully.
And the number 4.
Which one was that?
On the same piece.
Oh, the graph. So depending on the version you have a different graph. Well, one graph was like this. Up at 1 there was a point, and then down at the x-axis there was a hole. And there was a segment. And then it jumped up here to 1. And a segment. So 2, 1. Then it jumped up to 2 with a single point. And then it went all the way here. That's where it came down. Something like this. But I only asked you for about c equals 1 and c equals 2. So I asked you the limit. I asked you both the limit as x goes to 1 of the function. And I asked you f of 1. So what's the limit as x goes to 1 of this function? So that was for the limit. For f of 1, there's actually a point there, so you go up to that point and you get 1. And then I had you do the same thing for 2. Limit as x goes to 2 of f of x. That guy's 1, right? The trend as x goes to 2. If you follow what's happening on your function as x approaches 2, you're approaching this hole, which is at a y value of 1. And then f of 2, that guy jumps up, right? F of 2 jumps up to a y value of 2. What about the limit? Well, it depends on your test, but what about the limit as x goes to pi of 4? Limit as x goes to pi of 4. It's a constant, so what's the answer? Just 4, right? This is a horizontal line, this is always 4. So it doesn't matter what x is going to, your y value is going to be going 4. And then if you're having trouble with the calculator one, please stay after and I can go through it with you on the calculator and we can figure it out. Okay. Other questions? I heard you were having I heard that you guys were having trouble with number 7 on 1.1, which kind of that's not good, I guess. So I'll talk about that quickly. I said I would. So this was the secant line problem. It said consider the function f of x equals 6x minus x squared. wants you to graph f and the secant lines passing through the point 2,8 and qx comma f of x for x equals 3, 2.5, and 1.5. So, whatever, it wants you to graph a bunch of stuff. So let's start off by graphing that. What does this function look like in one? It's a downward parabola, and where should I place it, and how do you know?
The x.
Yeah, one thing you do is calculate the vertex. Okay. The other thing that's useful are the x-intercepts. Intercepts are always good when you're graphing. So I would probably factor this myself, right? Because you can pull out an x pretty easily. And then it becomes clear that the x-intercepts are when x equals 0 or x equals 6. So you know this is a downward parabola with intercepts at 0 and 6. The vertex will occur at x equals 3 because that's right in the middle of 0 and 6, but it's not a huge deal right now. So this is a good enough graph. Now, what might be confusing is it says graph the secant lines to the point 2,8 and then q equals the point x comma f of x. So I guess that's kind of confusing. This function is f of x. The point 2,8, 1, 2, 3, 4, 5. The point 2,8 would be somewhere up here. And this q, this weird notation they use, the point q is given by x comma f of x, and then they give you possible values for x. So they tell you x should equal 3 or 2.5 or 1.5. And so they want you to plot the point like 3 comma f of 3 or 2.5 comma f of 2.5 and 1.5 comma f of 1.5. They want you to plot each of those and draw the secant line. Right, so you go up to your graph at 3. That's one possible value of q. Or you can do 2.5. Or you can do 1.5. And what they want every time is the secant line that goes through P. So you can get a bunch of different secant lines. The one that goes through 3 and 2 looks like this. Right, the one that goes through 2 and 2.5 looks like this. The one that goes through 1.5 and 2 and you're supposed to find the slope of all of those in part B. So you actually probably want to figure out exactly what these points are, right? So actually plug 3 in, because you're going to need those points to find the slope each time, right? So this one is 3 comma 9, because when you plug 3 in, you get 18 minus 9. I don't know what these are. Did anybody do these?
2.5 and 8.75.
2.5, 8.75. So when you plug 2.5 in here, you get our 8.75. And what about for 1.5?
6.75.
So these are the actual points here that I didn't label. So part A is just the graph. Part B, we have to come over here and actually calculate some slopes. So we would do m equals, and we would use, first do P and Q with 3 comma 9. So like 9 minus 8 over 3 minus 2. This guy here is, so you're just calculating slope formula, 9 minus 8, 3 minus 2. So that gives you 1. And then you do that for each of the lines, each of the secant lines. So this guy, because he was 2.5 comma 8.75, you would do 8.75 minus 8 and 2.5 minus 2. So 0.75 over 0.5. 1.5. And then you would do the same thing with this point down here, which is 1.5 comma 6.75. So 6.75 minus 8 over 1.5 minus 2. So negative, I guess I did this. It's kind of funny. Negative 1.25 over 0.5. So this is like 2.5.
Mm-hmm.
So, it's just some busy work. But the point is, at the end of the day, you want to find in part C, you want to estimate or guess the slope of the tangent line. The tangent line is the tangent line through the point 2, 8. So the tangent line is the guy that doesn't hit 2 points, it actually only hits your graph at a single point. So it's this line here. The tangent line. It just hits once. So, depending on how hardcore you want to be about this, you could say, well, my slope should probably be between this slope, the slope between p and 1.5, and the slope between p and 2.5. So it's going to be between these two, just by looking at it, because the line is between those two lines. So you could just make an easy guess and say the slope of the tangent line is 2, because that's right in the middle of these two. If you wanted to do better, if you were not convinced that the slope of the tangent line is 2, what could you do?
Point zero closer to P.
Yeah, pick a point closer to P. Right? We did 2.5 and we did 1.5, but those aren't actually very close to 2. Right? You could get way closer to 2. You could do like 2.001 or something. Right? So if you wanted to verify this, you could calculate f of 2.001 minus f of 2 over 2.001 minus 2. Like you could do this same procedure, but plug in 2.001 instead. Something really close to this x value. And you should get 2, or approximately. So that's what number 7 is about. Questions?
Can you do 34 and 1.2?
1.2?
Yeah.
So, I don't want to waste a lot of time on this. But let me say something about it. So it wants you to, first it gives you this limit. It wants you to talk about the limit as x goes to 6 of 6 minus x over 3.
No, number 30.
Oh, 30, not 34.
30.
30, okay. So 30 is probably similar. So it gives you the graph of 1 over x minus 1. It shows you a graph, and then it says, find delta such that if absolute value of x minus 2 is less than delta, then the absolute value of x minus 1 is less than 0.001. Find delta such that if 0 is less than absolute value of x minus 2 less than delta, then I got these numbers right. Then f of x minus 1 is less than 0.0. So, I actually don't want to spend a lot of time on this, but I will show you what to do just as a reminder. The graph that they give you looks should look something like this. We don't care about the other side because we're only worried about what's happening as x goes to 2. Okay, so remember, this is sort of the formal definition of the limit, right? And what this is saying is that the idea is as x gets closer, gets within a certain tolerance of 2, then f of x should be within a certain tolerance of 1. So on my graph here, I have maybe 2, 1 at this point. And what it's saying is, if you take a 0.01 tolerance around 1, so 0.01 tolerance, if you go up 0.01, this would be 1.01. And if you go down 0.01, this would be 0.99. The question is, what is the corresponding tolerance around 2 that you can use to make sure that you end up with this correct region here? So we need to kind of figure out how far we can go around 2 so that we stay within this tolerance on the y-axis. So what you do is you basically have to figure out what these points are, what the x values of these points are. So you take your function and you set it equal to each of these y values. Right? So you have to solve 1 over x minus 1 equals 1.01. Then you have to solve 1 over x minus 1 equals 0.99. Right, after you solve those, that will give you x values down here, and once you have these x values, then you can figure out how far those x values are away from 2. So you can figure out that distance. You can try. I mean, you would have to multiply up. You'd multiply by x minus 1, and then you'd add, you multiply it out, and then you have a linear equation to solve. But I can finish it with you after class, but this is the start. Okay? Sure. Absolutely. Everything I say might be on the exam, so there's no need to ask me that. Everything I say. They're okay. They're okay. I mean, if I had to give you a probability it was going to be on the exam, it wouldn't be 100%. Maybe like 50 or 40, something like that. Definitely try to figure one of them out, though. Make sure that you at least kind of understand what's going on there. I did a couple last time as well, so once I post that video up, you'll be able to look at those and see how I did. All right, I need to talk about one. Finish that today. Oh. Actually, let me give you some quick review examples here. Just with the stuff that we ended on in 1.3. So if I ask you, let's say, find the limit, and I give you something like limit as x goes to 0 of, I don't know, x divided by sine of 5x. Remember how these work? Yep. So remember these limits of this form. If you plug in the x, you get 0 over 0. So that isn't going to get you anywhere. Okay. So what you need to do is refer to those two. We had two kind of identities, right? The limit as x goes to 0. Actually, I think we call it theta. As theta goes to 0, of sine theta over theta is equal to what? 1. This guy's 1. And then there's a cosine limit as well. The limit as theta goes to 0, 1 minus cos theta. That one's 0. Okay, so these are kind of your go-to guys for limits of this form. But the problem here is that this does not exactly fit this, right? Because this 5x and this x don't match, first of all. It's flipped over, but that actually doesn't matter too much. But the fact that the 5x and the x don't match is a big deal. So you have to make these match before you can apply this. So how do you do that? Multiply by 5 here, but then you have to do it to the bottom as well. Right, this 5 we want to pull out of the limit because it has nothing to do with the form we're trying to get to. So you multiply by 5 over 5 to make it fit the form, but then pull out the extra one on the bottom. So this 5 is going to get yanked outside. So I'll have 5x over sine 5x. The other thing you might be worried about is that we need theta to go to 0, right? We need whatever this quantity is to go to 0, but if x is going to 0, then 5x is also going to 0. Right? Those two things are actually equivalent. Whether 5x goes to 0 or x goes to 0, it's the same idea. You're still approaching the same point. So now I can apply this rule here, and I get 1 for this whole limit. Do you guys understand that the fact that this is flipped doesn't matter?
Yeah.
Right? Because if this limit is 1, then if I take the reciprocal, it'll be 1 over 1. It'll flip, but it's still 1. Okay, so this guy becomes 1, and the 1/5 stays. So you get that. It's not, okay, this is not true, but say this were 2. Say I said we had a formula that said this limit was 2. Then what would that change in my work over here? Yeah, then when you do this limit, instead of, you have to flip 2 instead of flipping 1. Sort of a side example. Suppose I know the limit as x goes to some number, say 5, of f of x equals 20. Then I know the limit as x goes to 5 of the reciprocal equals 1 over 20. So that's all. All right. Okay. I have a couple more just to make sure you get this here. What about something like the limit as x goes to pi over 2 of sine x over x? What do you think this should be?
Can you just plug it in?
Right. Right. This one is a problem because if you put 0 in, it's undefined. 0 over 0, indeterminate form. This one's not a problem because if you put pi over 2 in, you get sine of pi over 2 and pi over 2. So this is not an indeterminate form. You can just plug this in. What's sine of pi over 2? 1. 1 over pi over 2. So if you're not going to 0 here, you can't apply this limit, and in a lot of cases you'll just be able to plug it in. Okay, I got one more. So how would you tackle this one?
Shouldn't you just cancel out?
Cancel these?
No.
No, that's bad. If If this were multiplication, well, if it were like this times this, you could, but cosine, this isn't multiplication, this is a function. So this is cosine of this. So you can't cancel.
E equals 0.
0.
One less place.
I don't think it equals 0. Why does it equal 0?
Your theta's the...
Okay, so what, man? Good, good. Some of you fell for my trick. That's good. That makes me feel a little better. In this case, you think these match, right? You think these are your thetas, right? Because I purposely made it look like this. But if that's the case, then you need x plus pi over 2 to go to 0. But as x goes to 0, x plus pi over 2 doesn't go to 0. You see what I'm saying? So if x is going to 0, x plus pi over 2 goes to pi over 2. So this doesn't match this format because theta is not going to 0. In fact, you don't need to do anything that tricky. Yeah, you can just plug it in. You can just plug it in. Because if you plug 0 in for x, the denominator is not 0. If you plug 0 in for x here, well, it doesn't matter. The denominator is not 0. So you can just plug it in this case. So you'll get 1 minus cos pi over 2, because this is 0, over pi over 2. Cosine of pi over 2 is 0. So 2 over pi. So when it's multiplication, right, see here how it's 5 times x and 5 times x? Then it's okay because as x goes to 0, 5x goes to 0. But if you add an extra constant here, these aren't going to apply.